Theories of highly advanced ancient civilizations often face a logical dead end, the fuel source. Complex machinery like vimanas, the aerial vehicles described in ancient Sanskrit epics, cannot stay aloft on wood or charcoal. To move a heavy craft through the sky, you need high-density, portable energy. Modern electrical engineering bridges this energy gap using individual battery cells wired together. Conventional history, however, assumes that the chemical principles behind the battery were entirely unknown to the ancient world. For the artifacts and machines described in ancient texts to be functional, there would have to be a missing high-capacity power framework capable of driving industrial metallurgy or flight. Evidence of that framework appears in the Agastya Samhita. This ancient text functions as a technical manual, providing a specific list of materials to construct a foundational energy device. The assembly begins with ordinary physical materials, starting with the primary earthen vessels seen here. These terracotta pots serve as the protective housing for the individual energy cells. Inside the pot, the text calls for a copper plate, copper sulfate, wet sawdust, zinc amalgam, and a carbon rod. This is a precise recipe for a wet cell battery, sharing the exact chemical architecture of a modern Daniell cell. The zinc acts as the anode, the copper as the cathode, and the sawdust maintains the electrolyte bridge. This specific chemical reaction produces a consistent, measurable result. A single terracotta cell constructed to these specifications generates a stable electrical potential of approximately 1.1 volts. While 1 volt is a functional start, it is insufficient for any industrial application. To power the world described in the texts, the ancient engineers needed a method to scale this potential into something much larger. In engineering, massive power is achieved through modularity. Rather than building one giant, unstable component, you interconnect thousands of small, identical units to multiply their total output. The Agastya Samhita details this exact scaling strategy. It describes taking hundreds of these clay vessels, represented by the rows of pots here, and linking them into a single, cohesive power system. These instructions for interconnecting cells move the device beyond a simple laboratory experiment and into the realm of grid-scale energy storage. Chaining cells in a series configuration allows their voltage to add up sequentially. This diagram shows the pots linking together, with each new cell driving the total voltage higher. If you wire 400 of these terracotta pots in a series, the math compounds. The resulting output is 440 volts, a high-voltage supply capable of driving heavy industrial machinery. To increase the current capacity, or amperage, these 440-volt strings are linked in parallel. This creates a dense, geometric grid of battery packs, providing the sustained power needed for long-term operations. This modular architecture is identical to systems used in modern electric vehicle battery packs, relying on thousands of small cells to move heavy multi-ton vehicles. By treating simple clay pots as modular building blocks, the ancient text provides the blueprints for transforming basic pottery into a high-voltage power plant. Why would an ancient society need such a massive industrial-grade current? The answer lies in what that electricity can do to water. High-voltage current driven through water triggers electrolysis. The electricity breaks the chemical bonds, forcing the water to separate into two rising streams of gas. The Agastya Samhita identifies these gas outputs as pranavayu and udanavayu, the Sanskrit terms for oxygen and hydrogen. The Hoffman voltammeter shown here is the modern standard for capturing the exact gases described in the ancient text. Pure hydrogen is the most energy-dense fuel available. When ignited, it releases the intense thermal energy and high-velocity thrust required for advanced propulsion systems. This capacity for high-heat combustion connects the battery grid to flying vehicles and advanced metallurgy. Hydrogen provides the combustible force to propel a vimana and the extreme heat required for the craftsman seen here to work with specialized metals. The Agastya battery provides a theoretical framework for manufacturing high-potency fuel from water. It suggests that the chemical foundations for industrial-grade power and hydrogen production were understood and scaled long before the modern era.